Welcome to Microsoft Build 2017. My name is Tara, and I'm a Senior Technical Product Manager with the Cloud and Enterprise Data Division. Today we're going to talk about developing applications using SQL Server on Linux, Entity Framework, Docker Containers, Azure, and DevOps. Before we move into the demo and talk about how these things come together and build an application which is modern, let's have a look into the highlights of SQL Server on Linux. As you can see, SQL Server on Linux provides you all those features which are available to you guys today on Windows. Transparent data encryption, always encrypted, row-level security, in-memory column store. You ask for the feature and it's there. And the footprint of SQL across on-prem and clouds is just similar. In this session, you would see how we're going to bring in an application named Bike Sharing 360 to our local on-prem box running on a MacBook and build in the container for SQL on Linux, and then build the app on top of it. Some of the key takeaways we want you to take back from this session. First, easy acquisition and installation. You can install SQL on Linux on a Docker container or bare metal machine in less than 60 seconds. Second, we want you to take back with you advanced capabilities of SQL Server on Linux today, like in-memory, column store, and more. Last but not the least, choice of platform, on-prem or cloud. This is the same SQL you know, but it's now native to Linux. As you can see on your screens, we are talking about an architecture which is built on microservices. And there is an application which customers are using for renting bikes. We kind of showed this application back at Connect. And as you can see, the Bike Riders application is connected back into Azure SQL database. All right. And there's a lot more into this whole architecture, but we're going to concentrate on how we're going to pull this application on-prem and build a similar code base on top of SQL on Linux. Some of the challenges before we get into the demo. The first challenge Bike Sharing 360 is kind of dealing with at the moment is a rapid pace. And one of the criteria for bike sharing to be successful in the business is to be sure about their compliance and security credentials, and at the same time performance. Two of the major challenges or problems which Bike Sharing 360 is facing with the application is the slow performance of the home page because of a widget. And second, they really want to enhance their data security on the application side of things because it stores customers' profiles and personally identifiable information. All right. Let's jump into the demo and have a look at that. How Bike Sharing 360 is developing these applications on SQL Server on Linux, Entity Framework, Azure, and DevOps. As you can see, I'm running my Docker container here. And SQL Server is containerized into this application here. We haven't containerized the application, though you could always do that. As you can see, we are running SQL Server on Linux, CDP 2.0, on this particular box. Beautiful. What I've done, though, here is I have actually pulled the source code of Bike Sharing 360, for which we have the source codes available on GitHub, to my local box. I'm running on a MacBook, and I'm using Visual Studio Code to deploy and develop my applications here. As you can see, this complete application is built on Entity Framework. And we are using this so as to reduce any efforts that developers have to do to access data. All right. Now, as you can see this application closely, we have been trying to enable some of the model builders for the in-memory tables and the tables which are disk-based. We'll talk about more in terms of how we're solving this challenge which Bike Sharing 360 has with performance, and how we're bringing these advanced features of SQL Server on Linux, or SQL Server in general, like in-memory OLTP or columns to index to solve the problem. Okay, now as you've looked into the code, and there's a lot more into it, there's the profiles controller, which we're talking about where the customer information is stored. There's a rights controller, C# file, and this whole application is based on .NET Core. Okay. Let's look into this application and run it first. And with the help of a REST API client, we'll go and solve the problem we have currently today. OK. So I'm on my terminal. I'm just going to do a .NET run. And as you could see, I'm connected to my local host, and my database is Bike Sharing rights in memory. All right. Now let's go back to that REST API client and go and issue some of these API commands against this application to see how long are we taking to kind of retrieve the results back from the database tables. As mentioned, The problem Bike Sharing 360 is facing at the moment is performance. The API we have built here is rides distance. Okay, what is it doing? As the query is running at the moment, it's actually calculating the total trip traveled by the bike riders who have rented the bikes. And as you could see, it runs for around 3 seconds, which is around 3098 milliseconds. For an application as rich as Bike Sharing 360, which is so enterprisey, it's very important for Bike Sharing 360 to reduce this time frame. How do we do that, right? Okay, so what we're going to do is we're going to go and enable something, which is the in-memory support within Entity Framework. And while we enable that, we'll come back and rerun this application and then see the time frame and the difference. Now, to be realistic, as we ran the application for the first time, you could see the wait time was pretty long, right? Let's run this app once again so that the data which is in the cache shows a better result, and we will go with that as the benchmark. More realistic, 482 milliseconds is what we'll take for this base table against which we're running the query, which is an analytical query and trying to find the total trip distance traveled by the bike riders. Okay, let's go back to the app. Let's stop it first for a moment. And I'm going to clear this up a bit. And what we're going to do is a very simple change. We're going to go back to our RidesDB context. And as you can see, just one single line of change, and that will bring my tables into in-memory with the help of Entity Framework. It's a pretty big deal on itself, right? In general, if you have to do this work on SQL Server from Management Studio, you have to actually work through quite a bit of a logic, put the file groups, create the file groups for in-memory optimized tables, and then move the table. But it's just a one line of change, and your table is in memory. Pretty big deal. Okay, now once we do that, we just go back and rerun the application. Okay, so let me just go and run that. And also what I've done here is, just to save some time for the demo purposes, we have also built the column store index, because we are running an analytical query, and column store index will give you a great batch mode processing, compress the data on the data pages to bring the query execution time to more realistic timeframes. And column store index really helps analytical queries in its best possible way. All right, so let me just show you the code we have done or run against the tables to kind of bring the column store index into reality. So we have just altered the table rights and added an index CCI index clustered column store to enable column store index. What it does is it actually brings operational analytics into SQL Server. Think about this. You're running in memory for performance, and you're also including column store index to ensure that your analytical queries are processing faster in a performant way, and also compressing your data pages to reduce the disk size. Awesome. Okay, now that we have this both here, we're going to go and run the application, test the performance, and do the rest of the things after that. So let me go back to the app. And again, what we have done is, to ensure that we don't go through the whole migration cycle right now, we have also created another API, which is the in-memory table API, where the application has already been hosted. So one of the APIs is already pointing to the in-memory tables at the moment. So let's have a look at that. So we're going to pick the other API, where we have already included the Entity Framework corresponds and changes. And now what we're going to do is we're going to run this and see the results. So as we're running the app again, we will run this 2 times as we did it for the first moment of the application run against the disk space table. So let's go run this. Cool. So 2.5 seconds. Fair enough. Again, the wait time was the case. Let's go and run this one more time. 24 seconds. This is great, right? Almost 20 to 30 times performance benefit just by making one quick change, right? So we brought in in-memory tables with the help of Entity Framework, we enabled it, also kind of implemented column store index on top of the table because we are processing some analytical queries, and look at the result. It's awesome. Okay, we can't stop right there. As you saw in one of the slide decks we presented some time back, there was one of the biggest challenges with the compliance and security which Bike Sharing 360 needs to manage. If you recall the architecture we showed, we're talking about storing customer profiles where their names, email addresses are stored in the SQL database. All right. What we want to do is we want to go and create an impression on the application side of things that everything is masked, so nobody can see what exactly the email address is or the phone numbers are. Let's pick one of the fields and go mask it right now with the help of a feature called dynamic data masking. There's a numerous set of features available to you in terms of security, always encrypted, transparent data encryption, row-level security, and a lot more. But for this particular example, we're going to look into dynamic data masking. Okay, so let me go back to the app and show you what we have here. Interestingly, when we enable or disable dynamic data masking, it's completely transparent to the application. So these changes are only done on the database side, and there's no application downtime. Okay, let's just cross-check if our application is still running. Let it run, which is cool. We just want to make sure that it is running. I'm going to go and enable dynamic data masking on this table. So while I do this, I'm using Visual Studio MS SQL extensions. I'm going to run Command-Shift-T, and we're going to run it against the local host bike sharing rights memory using this SA account. Done. Okay, now we enable this, and just want to quickly show you how we can disable dynamic data masking as well. And then we'll go back into this application once again. So let's go and run this guy against this guy here, and done. So you can see this is like a very simple operation running completely on SQL Server side of things. Let's go back and look into the REST API client and pick up our profiles API, which is basically helping me find all the details about the customer's data, which is stored in SQL Server. As you can see here very closely, that we do have some of these guys details, right? We have some of the information highlighted and mentioned here, which is completely in clear text. So Scott Guthrie, Satya's, Tara, all of these information is in clear text. If you see their information of emails, right? We may want to mask most of the fields, but I'm interested in, let's say, email for now. Okay, so this was one of the second problems which Bike Sharing 360 is dealing with. Okay, let's go back to the Visual Studio Code. So you saw what we did, right? We just will go back to the dynamic data masking.sql and enable the mask function named email. Just going to go copy that, Command-Shift-E, and run this, right? Again, cross-checking, the application is still running, right? So there's no application level changes. And let's go back again to this API and let's run this. And now I could see that this is all masked. Amazing, isn't it? Wow, great. Now this is just one part, right? What we talked about initially was we're going to bring down this application to our local machines. So we brought this application to a MacBook, ran SQL Server on Linux, used Visual Studio Code extensions to test some of the application features and SQL Server advanced features. Now, once we're done with it, what we want to do is we want to create a migration script, submit that to our VSTS pipeline or CI/CD pipeline, and then commit those changes to stage, which is basically an Azure SQL database. As you recall, that our application is running against an Azure SQL database in production. All right, so we're going to do those steps and see whether our changes are remaining to be the same when we go to the cloud. So this is the third part of the key takeaways we're talking about at the moment. Okay, so let's go back. And the first thing now we want to do is come here, stop the app, just clear this a bit, and then we're going to run migration script SQL migrate.sql. Okay, so that should create a file somewhere here. So we should see within the SQL folder a migrate.sql file, and I'll show you how that migration file looks like. Okay, brilliant. Let's go back, and now you should see the migrate.sql file. Let's close this bit here and this guy here a bit, and now you could see. I'm going to save it. Beautiful. Now that I have a complete migration script ready for me to be deployed into the CI/CD pipeline or VSTS repo, which will forward be applied to the staging or the production environment, right? So have a look at this. It has got all of that we need, like the memory optimized tables to the DDM or dynamic data masking, the column store. Everything is in one single script. And because my VSTS pipeline is completely integrated to my GitHub repo, I could just go and make these changes and commit that to staging right away. So let's say commit to stage, and I'm going to go and make those changes committed. To save the time for this demo, we have already the source code of the migration script and applied that into the staging environment. Let's go and quickly flip that connection string and see if things still work. Okay, so let's go back into the terminal, and we just need to do one quick thing, and that is export ASP.NET core underscore environment is equal to stage. Once we do that and we run this application one more time, you should see now I'm connecting to my Azure SQL database, which is running in the cloud, right? Just a flip of connection string and we're there. Now we're going to go and test the same feature. We could do all of the feature testing, but we'll just pick, let's say, dynamic data masking and just check if it's working against the profiles API. All right, let's go back and look into it. So we're here, right? And we're going to go and send a query. And look at that. We're still masked. All right, this is an example of how you can acquire SQL on Linux running on Docker containers, bring that application on-prem, make the changes you need right away, and bring in all the advanced features of SQL Server, which is available to you on Linux. Implement those changes, commit those changes using the VSTS repo or CI/CD pipeline into your staging environments, and then you could see it's exactly the same SQL, which but it's now native to Linux. All right, thank you so much for watching this. But before we just go ahead and end the session, I want to give you guys some of the things to kind of a call to action so that you can go and play with the repos, play with the code, and build something which you can actually think of using SQL on Linux and contribute to our repos. As you can see on the screens, there's some of the repos we have already highlighted. There's some code stacks. There is this immersion, which we are building for hands-on labs access across SQL on Linux and other SQL Server and Azure data services. And if you want to know more about SQL on Linux, you can go to the landing page. Keep looking at our Channel 9 videos and also Microsoft Virtual Academy. Thanks so much for watching. Have a good day.